Hi everyone, my name is Arya. I'm from Advisory F. Today I'll be presenting my physics project. For a big question, why do visionary leaders adapt? For the focus question, how can human analyze transformation based on physics concept and law in a day-to-day life activities? Moving on to the outcomes, there is two outcomes that we learn in this term. The first one is able to develop a forward-thinking design based on the understanding of Newton's law of motion. The second one is able to analyze a daily life problem based on the principle of work, energy, and power. From these photos, there is me celebrating my 3rd birthday. We can analyze 4 physics concepts. The first one is normal force, the second one is mass, the third one is gravitational force, and the last one is frictions. So for the first physics concept, normal force. In these photos, the normal force is shown on the arrow that is heading to the up, pointing to the up. It is pointing to the up because normal force is the opposite direction of an object landing on a surface, and then the gravitational force is the opposite of normal force, which is heading down and shown on the arrow that is pointing down. For the frictions, it is between the cake and the table. It is shown on the below and heading to the right because there is frictions between two objects. And next we're moving on to the Newton's law of motion. The first one is Newton's first law. If an object is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. So in these pictures, in these photos, we can see there's no actions and the force will remains the same. And the second Newton's law is Newton's third law. The force given by the cake to the table, they apply force to one another. They are equal in magnitude and opposite in directions. So the force that is given by the cake to the table is equal, and there is no changes because there is no actions but only a mass that is giving a force to the table. Next, for the second photos, there is me riding a bike, and in these photos there is 4 physics concepts. The first one is normal force, the second one is mass, the third one is gravitational force, and the last one is application force. In these photos we can analyze that the normal force is heading up and the gravitational force is heading down, the same like the first photos, which have the same concept. For the applied force, it is shown on an arrow that is pointing down. I was sitting on the bike, which give force to the bike, and it is called applied force. Next, for the Newton's law of motions. The Newton's law of motion that I found on the photos is Newton's second law. When a force is applied to an object constantly, then it will have acceleration. And for the next Newton's law is Newton's third law. Since I ride the bike up and down, the bike exerts the same amount of force as I did. Moving on to the next photos. In these photos there is me sliding in a slide, and there is 6 physics concepts. The first one is normal force, the second one is mass, the third one is height, the fourth one is gravitational force, the fifth one is frictions, and the last one is applied force. We can analyze the free body diagram. In these photos, the normal force is heading up. It is shown on the arrows that point up, and for the gravitational force is the opposite of normal force, which is pointing down. And next, for the frictions, we can see that there is frictions between me and the slide while I was going down. And the applied force is also shown when I was going down the slide because the acceleration is increased while I was going down. The Newton's law of motions that is seen on the photos is Newton's second law. It is a quantitative description of the changes that a force can produce on the motion of a body, which I was sliding in the pictures and I accelerate. To make it clear, I make some kind of triangle which shows the positions from I was beginning in A, from my beginning positions, and then B, and then C. Moving on to the calculation. So in this calculation we use the law of conservation of energy. The formula for potential energy is mass times height times gravity, and for the formula for kinetic energy is one and a half times mass times velocity velocity square. And then from the pictures, the mass is 18 kilograms, which is my weight when I was 5 years old. Yes, around 5. And then the gravity is 10 meter per second quadrat, and the height is 2 meter, and the velocity is 0 meter per second. So first one, let's find for position A. For this potential energy, we multiply the mass, height, and gravity, which is 18 multiplied by 2 and multiplied by 10, which equal 360 joule. And next for the kinetic energy, it is 1 and a half multiply mass and multiply velocity square, which is the mass is 18 and the velocity is 0, so it equal 0 joule. So to find the mechanical energy, we have to add the potential energy with kinetic energy, which is 360 plus 0 equal to 360 joule. And for the position B, we do the same calculation like A, which to find the potential energy, we multiply the mass, height, and gravity, which is 18 multiplied by 1 and multiplied by 10, equal to 180 joule. But in position B, to find the key E, we must subtract the mechanical energy with potential energy, which is 360 subtract by 180 equal to 180 joule. Because we haven't found the velocity in position B, so we can use the kinetic energy to find the velocity. So the formula is 180 equal to half times 18 times velocity square, and then 180 equal to 9 times velocity square, and then 20 equal to velocity square, and then the final result is square root 20, which is 4.47 meter per second. And next for the position C, to find the potential energy, we have to multiply mass, height, and gravity, which is 18 times 0 and then times 10 equal to 0 joule. And to find the key E, also the same like position B, which we subtract the mechanical energy with potential energy. 360 joule minus 0 joule equal to 360 joule. And then we also have to find the velocity in position C. So 360 equal a half times 18 times velocity square, and then 360 equal 9 times velocity square, and then 40 equal velocity square. Then we square root the 40, which equal to 6.32 meter per second.